component of lipid is fatty acid. Fatty acid is an organic acid and has COOH and CH3 methyl N at the end of the change. So for the length of the carbon change for the fatty acid have even number of carbon in change. There is up to 24 carbon, and for the long chain we can find it in the meat, fish and vegetable oil, and for the medium and short change we can find it in the dairy products. And for the degree of unsaturation of the fatty acid is for saturated fatty acid, it is fully loaded with the hydrogen and single bonds. That means it don't have the double bond, and saturated fatty acid is more stable. For unsaturated fatty acid has double bond and has a band shape, and for polyunsaturated fatty acid has two or more carbon double bond. The location of double bond in the fatty acid, first we have the polyunsaturated fatty acid, whereas polyunsaturated fatty acid is in the position of the double bond that nearest with the methyl N, and that is we call as omega number. And monounsaturated fatty acid have only one double bond, and it stands to omega 9 group. Next we go to the types of the lipid. First we have the triglyceride. Triglyceride is composed of the three fatty acids that attach to the glycerol and by the condensation reaction. So degree of unsaturation revisite is cause the firmness of the triglyceride. Polyunsaturated vegetable oil is in the form of liquid, and for more saturated animal fat is in form of solid. The firmer of vegetable oil is because of the saturation, and the softer most animal fat is because of the shorter carbon change. If the shorter the carbon change, the softer the fat. Okay, for the stability, fat spoil when exposed to the oxygen, and oxidation fats will cause the smell and the taste rancid. For the polyunsaturated fat, it can spoil readily because it has a double bond and the change is unstable. So to protect the fat, we can seal in airtight, non-metallic container and refrigerated. And the other things that we can do is add the antioxidants in the fat. So next is the hydrogenation. For the hydrogenation, it has two advantages. First, it can protect against oxidation. That means the polyunsaturated fats can become more saturated, and it can alter the texture of the food, such as the liquid vegetable oil will become more solid when the hydrogenation occurs. Fat is also partially hydrogenated actually, and have some double bond will remain changed from cis to trans. And for the trans fatty acid is stable and has most double bond in cis trans. But for trans fatty acid, it is the hydrogen next to double bond are on opposite sides. Trans fatty acid is derived from the hydrogenation behave from light saturated fat. Next, we go to the another types of the lipid, that is the phospholipid. Phospholipid, base known as the lecithin, and the phospholipid in food is used as the emulsifier, and we can find it naturally in food. So the roles of phospholipid in role of phospholipid is phospholipid can soluble in both water and water and oil, and it can help fat soluble substance. Phospholipid also act as the emulsifier in the body and can helping to keep the fat suspended in the blood and the body fluid. Okay, lastly we have the sterols, the another types of lipid. And sterols is the compound with a multiple ring structure, and the sterols in food is derived from the plants and animal, and only those from animal that contain the significant amount of the cholesterol. So role of the sterols is many vitally important body compounds are sterol, and the cholesterol in the body can serve as starting material for synthesis of this compound, and cholesterol also can affect in the body when it accumulate in artery walls and contribute to the formation of plaque.
Digestion, absorption and transport of lipid. Apabila lemak masuk ke dalam mulut, salivary gland akan secrete lipids dan akan berlaku digestion di sini. Kemudian apabila masuk ke stomach, lemak akan bercampur dengan air dan juga asid dan diteruskan digestion. Namun di sini hanya separuh daripada lemak akan didigest, dan mostly digestion of lipid berlaku di small intestine. Lebihan lemak akan masuk ke dalam small intestine, dan di small intestine apabila lemak masuk ke small intestine, ia akan trigger hormon CCK iaitu cholecystokinin untuk trigger gallbladder untuk release bile. Pada peringkat ini, proses emulsification of fat oleh bile akan berlaku, di mana fat akan di emulsifikasi oleh bile, iaitu dengan bile akan membantu fat untuk bercampur dengan water untuk menjadi emulsified fat supaya enzim boleh mendigest fat. Untuk bile, selepas bile digunakan akan ada dua tempat yang dia akan pergi. Yang pertama, bile itu akan di-reabsorb dan di-recycle, dia akan digunakan semula. Dan lagi satu, bile mungkin akan terperangkap ke dalam fiber dan akan di-excreted in feces. Kemudian untuk lipid absorption, untuk small molecule of triglyceride, dia akan directly diffuse into the intestinal cell. Manakala untuk large molecule, dia akan merge into spherical complex known as micelles, dan kemudian akan ditransport oleh transport yang dinamakan cyclomicron.
Lipid in the body. Body can store a limited amount of fat when fat is considered in excess. Liver can convert excess carbohydrate and protein to fat. Fat need carbohydrate to break down efficiently. Kalau dia tak break down secara efficiently, fat akan form ketone bodies. Next is role of triglyceride. First is energy. Macam kita tahu, lemak akan menghasilkan energy. Insulation to maintain body temperature. Shock protection, structural material for cell membrane, and use carbohydrate and protein efficiently. Yalah, kalau triglyceride tak ada, macam mana nak guna carbohydrate and protein tu? Apa jadi dekat carbohydrate and protein tu? Next is essential fatty acid. Essential fatty acid means cannot made by body. Dia ada 3 jenis essential fatty acid. First, linoleic acid and omega 6 family, linoleic acid and omega 3 family, and eicosanoid. First is linoleic acid and omega 6 family. Can make arachidonic acid and supply by vegetable oils, also meats. And linoleic acid and omega 3 family supply by food, can make EPA and DHA. Dia sangat penting untuk mata, otak dan juga hati. Eicosanoid pula made from arachidonic acid and EPA. Dia menghasilkan hormon. Next is apa jadi kalau kita tak cukup fatty acid. Okay. Dia selalu berlaku kepada infants ataupun children. Macam orang yang tak cukup makan adalah selalu berlaku dekat South America. Simptomnya visual problems, kidney and liver disorder and reproductive failure, also sometimes masalah kulit. Last is lipid metabolism. Dia ada dua jenis lipid metabolism. First, storing fat as fat, and second is using fat for energy. Storing fat as fat, maksudnya kat sini dia simpan lemak tu dalam bentuk lemak. Dia akan menjadi energy for carbohydrate and protein. Dan kat mana lemak tu akan disimpan? Dekat dalam adipose tissue. Adipose tissue take up and stores triglyceride. Adipose tissue also secrete a hormone known as adipokines. Dia akan help regulate energy balance and influence several body function. Okay, nak kita tengok dia punya metabolism. Lipoprotein. Lipoprotein macam kita tahu dia adalah lipid carrier, akan mengangkut triglyceride dalam badan kita, dan triglyceride itu akan dihydrolyze oleh lipoprotein lipase menjadi fatty acid, diglyceride and monoglyceride. Lepas tu tiga jenis macam fatty acid, triglyceride dan monoglyceride ni akan disimpan dekat dalam adipose cell dan akan digunakan apabila energy dan storage diperlukan. Okay, last, using fat for energy. Dia ada 5 jenis. Dia simpan lemak dalam keadaan tenaga. First is hormone, menjadi sensitive lipase hydrolyze. Triglyceride, apabila dia akan simpan triglyceride dalam bentuk energi apabila kita memerlukan energi saja. Yang ketiga, apabila kita berlaku fasting, metabolize fatty body fat. Bila kita berpuasa, lemak tu akan disimpan dalam bentuk tenaga. Bila kita puasa, kita tak ada tenaga. Yang keempat, obtain energy from lean tissue. Yang kelima, complete breakdown of carbohydrate protein.